Okay, so this is the section on 4.2 translations. Translations of our two graphs, sine and cosine. This is when we shift these things left or right or up or down. And these are normally, this is the coolest name of anything we do, phase shift. um, this should be a really quick video. You've got step-by-step instructions in your textbook, but we're going to do this the easy way. We're going to do this just as easy as possible. If you add something to your x value, so this is directly to the x value, that does kind of the opposite of what you would think. That shifts you left. Right? When I think of adding, I think, well, that should move me to the right. That should move me in the positive direction. But it actually works the opposite. Subtracting some number, that would shift you to the right. So we do kind of the opposite of what those signs would make you think we do. Subtracting some number moves you to the right. Adding some number shifts you to the left. So for example, graph y equals sine of x minus pi. Well, here's my normal sine graph, this red one. Okay, so by subtracting pi, that actually moves me to the right. It moves me the distance of pi. So I just take each of my points and I shift it to the right a distance of pi. So my first point right here gets shifted to the right pi. Right, so that's where we'll be starting from. This high point at pi over 2, this gets shifted to the right pi. It gets shifted to right here. So pi is at 2 tick marks. We're shifting each of these things 2 tick marks. So from here I go over 1, 2. That gives me my new high point. Okay, so so I go from 0 to 1 and then back down to 0. Well, that was at pi, that gets shifted over to 2 pi. We just add pi to that. So we're just taking our whole graph, we're shifting every point over a distance of pi. So you can say this has a phase shift of pi, or it just has a horizontal translation of pi. Okay. Now this is kind of annoying. A lot of times you'll have, if you have a period change and a phase shift, you'll be given it in this kind of annoying form, and you will have to do this. You'll have to factor out whatever number is in front of your x. So for example, here I've got 3x plus pi. If I'm going to factor 3 out of each of these terms, well, it's really easy with the x. I just put a parenthesis right there. But what I'm doing when I'm factoring out something is I'm dividing that term by it. So I divide 3x by 3, I'm left with just x. If I divide pi by 3, well, I'm left with pi divided by 3. So that can be tricky, especially if you haven't factored in a while. Especially when it's something like this, when you're not entirely sure why we factored. We factor it this way so we can still apply our rules for dealing with the period, and we can figure out how to do this phase shift. So once we factor it out, our period is just 2 pi divided by this number, divided by this 3. And our phase shift is just this pi over 3 right here. Okay, so period we talked about in section 4.1. The phase shift is what we're talking about right now. This plus pi over 3 would shift us to the left pi over 3. Please tell me I've got that written. Yes, I do. Okay. So my basic graph of cosine normally starts at 1. What I did is I took that value and I shifted it over pi over 3 to the left. In order to find these intermediate values, I've got these instructions. They sound kind of crazy. There are a few techniques in order to do this. Since we're not graphing these things by hand, I don't think this is hugely important for you to know how to find each of these tick marks. In reality, you can use a And most people doing this nowadays would just use a computer to find these values in between. What the important idea is to realize that this has shifted us to the left pi over 3. That's the real meat of this. Adding pi over 3 to your variable shifts you to the left pi over 3. I'm not so concerned that you know how to find each of these other tick marks, pi over 6, etc. You can do it by taking your period divided by 4. So our period in this case is 2 pi divided by this 3 we factored out. If you were to then divide that by 4, you get 2 pi over 12, which is pi over 6. And each of your tick marks should be a distance of pi over 6. Alright, so I start at negative pi over 3. I go to negative pi over 6. That's a distance of pi over 6. That's also a distance of pi over 6 between 0 and negative pi over 6, between 0 and pi over 6. So that's one method of doing it, and I've got all that. I actually got that arithmetic written out. Okay, I took that period, 2 pi over 3, divided that by 4. I got 2 pi over 12. Simplify that to pi over 6. That's the distance between each of our tick marks. Okay. But again, that's only if you have to do it. You see in my MATLAB, I mean, they're not even all written in. No one's asking you to write those in. The important part is you get the general idea of where the shift moves you. So do I have a good question like that? So no, I don't even have a question like that. Okay. I have one going the other way. Actually, that's not too bad. Of course, this doesn't have a shift in it. All that talk about phase shifts, and I don't even have one. Well, that's really disappointing. I thought I included one. So this should be a really easy section for you if there's no phase shifts. Ah, there's a phase shift. Okay, I knew I had it in here. I was going to be very confused. So sine of x plus pi. Well, sine normally starts at 0, goes up to 1. So this is more like what sine normally looks like. Starts at 0, goes to 1. But I've now shifted that to the left pi. So if I shift that to the left pi, I should get this bad boy. So instead of starting at 0, going up to 1, coming back down, well, now I start right here. I've shifted over negative pi. Nice. Do I have any more of those? Maybe a couple. Okay, here I've got cosine with a phase shift of pi. Right. So this negative pi tells me I move right. Again, kind of contrary to what you would think. Cosine starts at 1 and goes to 0. Which one of these has been shifted over pi? That would be this one. So normally I start right here, but I've taken that point and moved it over to pi. Normally I cross right here, but I've taken that point and moved it over to pi. Normally at pi, that's where I hit my first trough, but now I've shifted that over 2 tick marks. Shifted that over pi as well. So not too bad. My MATLAB makes this really easy for you. They've just got your, if it's shifted over pi, well, your first tick mark should start at pi. If it's shifted to the left pi, well, it should be at negative pi. So I don't have you worrying so much about finding all these intermediate tick marks. That's kind of overkill, I think. You just need to know, because this is what people care about. Do you know that this means it has a phase shift? It got shifted left or right, or what have you. Okay. The other kind of translation, the same as when you took algebra, if you took algebra, if you've taken algebra recently. If I had to take some number and just add it to my function, that shifts it up, the whole thing. And now this is more like what you think of. A positive number shifts me up. So for example, 3 plus sine of x, it's our normal sine of x, but I shifted it up 3. If I've got a negative 2, for example here, a negative value, that would shift me down. So let's see if I've got a great example of that to pull up for you. Oh gosh, they're all at once. Okay, so I didn't include any of these. So that should make this easy for you. Okay. Now, combining all of these rules, that's what these last two problems are. Let's see if we can do one. So, these are nice. It gives you some choices. Choose the appropriate description of the following function. Y equals 3 cosine of 4x minus 7. So what we'll need to do is, first, I would identify the amplitude first, because that's the easiest one. Amplitude is 3. So that means amplitude 3, amplitude 3, amplitude 7. Okay, so choice C is out. That can't be right. It could be any of these other ones, A, B, or D. What about the period? Well, the period is found by taking this number in front of our x variable. We're going to divide 2 by that number. So in our case, 2 pi divided by 4. What is 2 pi divided by 4? Well, those are both divisible by 2. If I cancel out that 2 from each, I'm left with pi over 2. So my period, my new period should be pi over 2. So that would eliminate, we've already eliminated C. Now we've also just eliminated D, because that's 2 pi, not pi over 2. They wrote this a little differently. They wrote 1/2 pi, but that's the same as pi over 2. Okay, so now we're between choice A and B. The only difference is the phase shift. So we've got this 7/4 or we've got 7. Which one is it? Well, remember that in order to find our phase shift, we need to factor out this number. So we're dividing this 7 by 4. And that should give us this phase shift of 7/4. And notice that it's negative here, but when we talk about the phase shift, we're talking about this positive number that shifts us to the right 7/4. So that's it. We've got to have choice A in this case. Check answer. Yay. This one should be similar. Amplitude's the easy one. That's 3. The period is 2 pi divided by our 6 there. Two pi divided by 6, those are both divisible by 2. I cancel out a 2 there, cancel out a 2 there. I'm left with 3. So I should have a period of 1/3 there. So it's got to be one of these two. And finally, what is my phase shift? Well, I take my 5, I divide it by 6. I should get 5/6. And that tells me I've got to have this one. Now, graphing that would be kind of a pain. We could still do it. Gosh, I don't know how to do this on the computer. Well, it oscillates between positive 3 and negative 3. Our period is much smaller, so this would be kind of scrunched. It wouldn't be nearly as wide. And it's shifted to the left, this 5/6. It's to be shifted a little bit. Sorry, it's shifted to the right 5/6. To be shifted over to the right a little bit. Okay. So that is it for 4.1 and 4.2. I'll close this out and